All right, so this is the second video in this stoichiometry limiting reactants series. This is a slightly more complicated problem. And again, this is a requested video, so thank you again to Madeline for the request. So in this problem, again, what we're going to want to do is start with the balanced chemical reaction. And if you're looking at this video and you're not really sure about one of the steps, check out the previous video. I go over the steps maybe in a little bit more detail. This is going to be a little bit more of an advanced video. So the first thing that I'm going to do is write out my chemical reaction. And in this case, this chemical reaction, when I first write it out, it's not balanced. So we always want to be checking to make sure that we have a balanced chemical reaction. And in this case, I can tell right away that this is not a balanced chemical reaction. And I can tell that basically because of the sodium. That's what really jumps out at me. So I've got one sodium on the left-hand side, but I have two sodiums on the right-hand side. So I need to go about and balance this chemical reaction. I'm going to need to put a 2 in front of the sodium, and I'm also going to need to put a 2 in front of the H2O. So if you are struggling with balancing that, I think I've got some other videos for balancing chemical reactions, but that's what we would want to start with. Now we're going to do sort of our grams to moles conversion. So I'm going to have 6.87 grams of sulfuric acid, 1.5 grams of the sodium hydroxide, and we're asked to calculate the maximum mass of water. That's what we're looking for, is how much water will be formed in this reaction. So like I said, step one, just going to be convert from grams into moles. Whenever we're dealing with limiting reactants, stoichiometry, balanced chemical reactions, we always want to be using moles because these coefficients 1 and 2 and 1 and 2, that's the number of moles. 1 mole of sulfuric acid needs 2 moles of sodium hydroxide to react to give 1 mole and 2 moles of water. So that's going to be step one, 6.87 grams of H2SO4 times 1 mole, and the molar mass for H2SO4 I calculated earlier is 98.09. So that's the number of grams, and that gives me 0.0700 moles of H2SO4. I'll do the same thing for the sodium hydroxide, so 1.5 grams NaOH times 1 mole over 40.0 grams equals 0.0375 moles of NaOH. So at this point, you really have two choices. You can sort of just try to look at the numbers and figure out what the limiting reactant is, or we could sort of do a systematic way to figure out which one of these is going to be the limiting. So now we need to say, well, which one is limiting? And there's a number of different ways to do that, a number of different strategies. One strategy that I really like to figure out the limiting reactant is might be a little bit different than what other people have seen or would suggest, but I like this method because it gives you the right answer every time, and you don't need to worry too much about it. So the way that I like to teach this, so over here we'll do 1A, so part 1A, is to find the number of reactions that each substance can sort of do. So reactions. And I'll take the number of moles, 0.0700 moles of H2SO4. And I'm going to multiply that by one reaction over whatever the coefficient is. So each reaction requires 1 mole of H2SO4. So I can see that I'm going to be able to do 0.0700 reactions with this amount of H2SO4. I'll do the same thing for sodium hydroxide. And remember that really the only reason that we're doing this is because we can't just directly compare these two numbers because the coefficients are not 1-to-1. If it's a 1-to-1 ratio, like in the previous video, yeah, we just look at this and say, well, the sodium hydroxide is a lower number, should be the limiting reactant, but that's not always going to be the case. So if you just want to double check, this is the way to double check. So 0.0375 moles of sodium hydroxide times one reaction requires 2 moles of NaOH. That tells me that with the sodium hydroxide, I can only do 0.01875 reactions. Now I'm going to compare the number of reactions that I got with, and this will tell me that sodium hydroxide, it can do less reactions. That tells me that sodium hydroxide must be the limiting reactant. So a slightly different way maybe to find out what the limiting reactant is, but once we have that limiting reactant, then everything becomes the same. So this method over here I think is nice to figure out what the limiting reactant is. Of course, there are other methods, but I like this one because it can directly tell you, just figure out how many reactions you can do, doing this calculation with the number of moles. Oops, should put in moles here. Number of moles of reactants, figure out how many reactions you can do, and then directly compare these two numbers. Now, once we have the limiting reactant, then I want to go back to using that number of moles of limiting reactant. So 0.0375 moles of sodium hydroxide, keep forgetting to put moles in there, times 2 moles of H2O, so now we're doing the stoichiometry, over 2 moles of sodium hydroxide, mole-to-mole ratio. Obviously we can see it's going to be 0.0375 moles of H2O. And then the last step is just going to be our moles to grams conversion. So step 3, 0.0375 moles of H2O times 18.02 grams per 1 mole. And that should give us 0.675 grams, which we can round to 0.68 grams. So that is my answer. I want 2 sig figs again in this problem because of this 1.5 grams. That would be the way that I would tell that. Only 2 sig figs in this initial number, so my answer should only have 2 sig figs. So this is this whole problem. A little bit obviously trickier, more involved in the previous version. Start with your balanced chemical reaction. Figure out what the limiting reactant is, right? And you can use this method or you can use some other method to do that. Once you have the limiting reactant, go back to the number of moles of your starting material. That's going to be the limiting reactant. Do your mole-to-mole conversion. This is what we call stoichiometry. And then finally a moles to grams conversion. All right, hope that helps.